All right, here's the big one, solving radical equations. This one's super important moving forward. The biggest thing here, and we'll see this as we go through this as well, is something called extraneous solutions. Extraneous, I think I said that right, I don't know. Anyways, what they are is they look like they're solutions, but they're really not. They're extra solutions that we get from solving, but aren't actually solutions in our equation. So the biggest thing we need to do is check our solutions as we go. Other than that, that's it. So let's jump in. Let's get to it. Glad you're here. All right. So we're just going to be solving for x. So just keep in mind what the inverse operation of the square root is. It's actually squaring. So what I would do first is get the square root by itself. So minus 3 square root of x equals 6. So now to get rid of that square root, the opposite operation would be to square both sides. So that will give me x equals 36. So like I said, go back and check your solution. If I take my x and I replace it with 36, the square root of 36 is 6. So I know 3 plus 6 is 9, so that's good. The main thing I'm checking for is that I'm not taking the square root of a negative number. So if I take the square root and I put in my solution, that would be the square root of 36, which would be fine. That is a solution right there. So no extraneous solutions. That one's good to go. I can't say that. Extraneous solutions. Extraneous solutions. Yes. Okay. All right. So again, get the square root by itself. So plus 17 on both sides. So I have root 2x equals 8. And then I will square both of those. So square and square. So I get to 2x equals 64. And then to get rid of the x by itself, I can divide by 2 on both sides. So that will give me x equals 32. Again, check your solution. 32 right here would be the square root of a positive number, so that's good to go. That is my solution. All right. So here, get the square root by itself. So I'm going to add 1 to both sides, so plus 1 plus 1. So this would be square root of x plus 5 equals 4. And then I can square both sides. So this will be x plus 5 equals 16. And then I just need to subtract that 5 over so that x equals 11. So again, check your solution. Make sure you're taking the square root of a positive number. So if I put in 11, 11 plus 5 is 16, positive. So I know that is good to go. All right, keep it going. Doing good. Yes. So minus 11, minus 11. So now I have square root 1 minus 3x equals 4. So then if I square both sides, to get rid of that square root, I have 1 minus 3x equals 16. And then I'm going to subtract the 1. So I have negative 3x, make sure you pull that negative down, equals 15. So then divide by negative 3. So x equals negative 5. So again, check your solution. Does negative 5 actually work? Well, if I have negative 3 times negative 5, that gives me positive 15. Plus 1 is positive 16, so that's a positive square root, so I'm good to go there. Yes! All right, here, this one looks crazy, right? But don't forget that this is the same thing as the square root of x plus 3 over x minus 1 equals 3. So what that allows me to do is now the square root is by itself, so I can square both sides, so that I get x plus 3 over x minus 1 equals 3. To get rid of this denominator, I can multiply by it on both sides, so that I have x plus 3 equals 3 times x minus 1, which is 3x minus 3, and then just keep solving. So add 3 plus 3 minus x, so that makes 0 and that makes 0. So I have 6 equals 2x, so when I divide by 2, that gives me x equals 3. So again, check your solution. Make sure it works in both of your square roots. 3 plus 3 is a positive number. Good. 3 minus 1 is a positive number. Good. So that's my solution. That one is good to go. Keep it moving. So again, get the square root by itself. Whoa, we have an x over here. But just keep working it the same way. So when I get to, I'm sorry, I just realized I said so a lot. I was probably going to keep happening. I'm sorry. I'm not trying to ignore you, I promise. All right. I do that one too. Ah, stop it. Okay. It's just, it's a thing. I just keep saying stuff. Square both sides. X minus 3 equals, remember, x minus 5 squared. You have to multiply this out. X minus 5 times x minus 5. So that would give me x squared minus 10x plus 25. So, we have a quadratic. When we have a quadratic, don't forget, you want to make it equal to 0 and then factor. I'm so sorry. All right, minus x plus 3. This gives me 0 equals x squared minus 11x plus 28. Now factor. X minus 4, x minus 7. Gives me solutions of x equals 4, x equals 7. Check both of them. Make sure they both work. Go back to your original function. 4, if I use 4, square root of 4 minus 3 is positive 1. That's fine. So I know you're good. 7 minus 3 is a positive 4. That's fine. So that's also good. All right, so both of those solutions work then. That's fine. Just be very, very, very careful as you guys through. Make sure all your solutions work. Okay. Part G here, what I would do first, we have 2 square roots, but what I would do first, kind of help yourselves out a little bit, is divide both sides by 2. Right? Because 2 divided by 2 makes 1, 2 divided by 2 makes 1. That makes it a little bit simpler to work with. So square root 2 minus 3x equals x root 5. All right. So we kind of have our square roots by themselves. We could divide the root 5 over and make that all one square root. That's fine if you want to do that. It makes no difference. It's not going to really change what we do anyways. So I'm going to really just go ahead and square both sides from right here. And that gives me 2 minus 3x equals, now notice, you're multiplying x root 5 times x root 5 here. So that's going to give me x squared times root 25. So this is just 5x squared. Again, we have a quadratic, so make it equal to 0. So 0 equals 5x squared. Add the 3x, so plus 3x. Subtract 2, so minus 2. Now let's try to factor this thing. So we have 0 equals 5x and x. So now in order to get 3, let's see if I do plus 1, that would give me plus 5. And then negative 2, so that's minus 2. So that is how we factor that one. Now this gives me x equals 2 over 5 and x equals negative 1. So now think about this. We've got to make sure both of these solutions work. We care about this 2 minus 3x right there. So if I do 2 minus 3 times 2 fifths, so let's check that out. 2 minus 3 times 2 over 5. It needs to be greater than 0 or equal to, either way. This is 2 minus 6 over 5. So 2 minus, 10 over 5 minus 6 over 5 will give me a positive number, so that's fine. That's no big deal. So that one is good to go. And then if I put in negative 1, negative 3 times negative 1 is a positive 3, so 3 plus 2 is 5, so that one is also good. So both of those are good solutions. Make sure you guys take the time and actually check it. All right. Notice we have a cube root now. So we have this little 3 on the outside tells us we have a cube root. What that's asking is what number times itself 3 times gives us the thing inside. So like if I took the cube root of 8, the cube root of 8 is 2, because 2 times 2 times 2 gives us 8. That's what a cube root is. All right, so just like a square root, to get rid of the cube root, what we're going to do to both sides is cube both sides. So to the third and to the third power. So it gives me x plus 7 equals 3 to the third is 27, minus 7 to the other side equals 20. That's it. Cool thing about cube roots is that if I were to take the cube root of negative 8, I can make that negative 2, because negative 2 times negative 2 times negative 2 would give me negative 8, right? Negative 2 times negative 2 is 4, times the negative 2 from there gives me negative 8. So cube roots, fifth roots, seventh roots, any odd number root can be a negative number. It's only our even number roots, like square root, 4th root, 6th root. Even number roots, they have to be positives, otherwise they're imaginary numbers. All right, moving on. I think we only got 2 more. Doing good. This is one of the longer ones. I'm sorry. I don't remember which one is the longest. All right, this one works the same way as our other one. So just notice it's a cube root, so it's the cube root of both of those things. So I can just go ahead and cube both sides. And this becomes 5x plus 1 over 2x minus 11 equals 8. And then I'll multiply that 2x minus 11 to the other side. So I have 5x plus 1 equals 16x minus 88. And then just keep solving. So minus 5x, and then plus 88, and then plus 88, 0 and 0. So I have 89 equals 11x, divide by the 11, and then x equals 89 over 11. Cube roots I don't even need to check because they can be negative. Makes no difference. All right, now for the monster. The monster. You'll see this one on your quiz, so I wanted to make sure that you guys knew how to solve it. All right, so I have a cube root by itself, so cool. So I need to cube and cube. Now that x minus 1 cubed, that's going to be a little bit of a beast, but just take your time multiplying it out. So on this side, super easy. It just gives me negative 2x squared plus 12x minus 10, and then equals, I'm going to take the time and write all 3 of these out for you guys, so you know where everything is coming from. So when you're multiplying 3 things together, only multiply 2 of them at a time. So it's going to be a little bit tedious, but I need to multiply those 2 first. So x squared minus 2x plus 1, now times the x minus 1. This side is going to stay the same. So now here, distribute that x squared to both terms. So that gives me x squared, x cubed, x squared times x, x cubed, minus x squared. Now distribute the negative 2x to both. So minus 2x squared plus 2x, and then distribute your 1 to both. So plus 1x minus 1. Combine like terms. Still this side is staying the same. So I have x cubed minus 3x squared plus 3x minus 1 equals this other side, negative 2x squared plus 12x minus 10. All right. Now we can actually keep working with it. So I'm going to make it equal 0 since I have a polynomial, and hopefully we can factor by grouping. So plus 2x squared minus 12x plus 10. So plus 2x squared minus 12x plus 10. That makes 0 on that side, so 0 equals x cubed minus x squared minus 9x plus 9. All right, now let's see if we can factor this by grouping. Let's try it exactly as I see it. So from these 2 terms, I can factor out x squared, so this stays x minus 1. And then from these 2 terms, I'm going to factor out a negative 9, so that this becomes x minus 1 as well. Factor by grouping. So now factor out the x minus 1, so this becomes x minus 1 times x squared minus 9. X squared minus 9 will factor, so I have x minus 1 times x plus 3 times x minus 3 equals 0, still 0, 0, 0. And I can find my solutions. Oh, finally. So x equals 1, x equals negative 3, and x equals 3. All 3 of those are good solutions. Again, you guys can take the time to check and make sure that they actually work. I would suggest it, obviously, but they should be good as long as your math is good for a cube root. Square roots, make sure that you are taking the square root of a positive number all the time. And that will be it. Yeah. All right. As always, please, 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 let me know what questions you guys got. I'm here for you. Just shoot me an email anytime. I'll see you soon. All right. Bye.